I don't talk a ton about my past on here, but I did spend some time in the military where I thoroughly enjoyed stuff that either deflagrated or detonated. With this year being the 250th year that the beautiful United States of America has been around, I decided to make something that has a red flame, a white flame, and a blue flame.
I am a certified instructor with the Bureau of Unconventional Live Fire Launch Safety, Handling, and Instructor Training. This gives me the ability to safely operate this flamethrower. Please do not try this at home.
Once again, do not try this at home. I am a licensed, trained professional and use extreme safety procedures when performing anything with a flame or anything with hazardous material. Once again, do not try this at home. By far, the most difficult part of this project was the white flame. I scoured the internet and spent so much time searching, but I was unable to find any recipes that ended up being in liquid form. I tried magnesium sulfate, sodium bicarbonate, and many other things. I also tried many different types of fuel, such as isopropyl alcohol, denatured alcohol, methanol, ethanol, but kept having the same issue. The chemicals I was trying to use would not properly dissolve in alcohol. I did try dissolving the chemicals into water, then dissolving the water into alcohol, but still did not have the results that I was looking for. Everything either came out blue or a yellow flame. I did get one minor success where the top of the flame was green, but the center of the flame was still blue. I'll probably use this in a future project somehow. After temporarily giving up on the white flame, I'm moving on to the red flame. First, I'll take a stir bar, place it in a beaker, then I'm going to throw in some lithium from a battery that I've disassembled. Once again, this is extremely dangerous and you should not attempt this at home unless you are a licensed, trained professional. I take out those big chunks of the battery as I wait for everything to dissolve into the alcohol. I left the stir plate on without any heat for about a half hour, and I was kind of disappointed at how many chunks there were still left over. After about a half hour, I took it outside and tested it out. As you can see, I have a beautiful red flame here. One of the issues I did have with this particular mix is there was large chunks of the lithium battery left behind, and this was clogging up the needle that I was using to spray. So to fix this issue, I'm switching to a different recipe where I'm using a different form of lithium. This time I'll be using lithium chloride, which dissolves in alcohol. Throw about 400 milliliters of denatured alcohol in a beaker, turn on the stir bar, and wait for everything to dissolve. One of the issues I had with this mixture is when I first go to ignite it, I only get a blue flame. The red flame doesn't appear until the liquid starts to heat up, which then allows the lithium to start to burn. For my project, it won't just be sitting in a cup burning. I'll use it in the spray form, so I'll go inside, grab a syringe, hook it up with this alcohol solution, then take it outside and spray it and see how it works. Once I know which form of lithium I'm going to use, now I just need to figure out the concentration. Next, I spend about the next half hour going through different concentrations of lithium chloride dissolved into alcohol, then diluting that solution down with alcohol to figure out the appropriate mixture I need for the flame.
1/3 of the mix, 2/3 straight denatured alcohol.
And I was extremely surprised how far I could dilute the lithium chloride down, but still get this beautiful red flame here. After accepting defeat on the white flame, that I was going to be able to make it out of anything sourced locally, I decided to buy some nitromethane. This box here cost me around $500, and as you can see, it has a beautiful white flame. The issue I had with the nitromethane is it's very energetic, but you need a little bit of alcohol in order to make it easier to ignite.
Okay, I have 30 milliliters of nitromethanol, and then this is filled with denatured alcohol. I am going to see if I can add a little bit of denatured alcohol to the nitromethanol,
and hopefully this will make it much easier to ignite. And because I want to get the most bang for my buck, I'm going to see how much denatured alcohol I can put into the nitromethanol. This will dilute it down and do two things. One, it'll make the nitromethane last longer, and two, it'll help it ignite. I continue to add denatured alcohol by 1 milliliter at a time until finally I start to see the flame becoming a little bit more blue. Then I back the mixture off just a little bit. And this flame seems very unnatural when you look at it. It's just weird to see just a pure black and white flame. I'll do one final flame test outside, then the only thing left to do is to actually start to build the flamethrower. Head over to the workbench, then we're going to get started on this build. It'll be electrically powered. I'll be using 12-volt fuel pumps, some tubing. Now I need to head down to the basement and grab some old furnace parts. I'm going to be using the orifice off of a natural gas furnace to spray some of these solutions into the air. I'm not sure what size orifice I'll be using, so I'll grab a few different styles and do some testing out on the workbench. Now mechanically, this is going to be an extremely basic setup. I've got a piece of tubing that's going from the fluid tank, then I'll be going to the pump, be going to the orifice and spraying it into the air. Electrically, I'll also need to figure out the power supply. The pump's pulling just below 5 amps. As I go outside for testing, for safety reasons, I'll have a few fire extinguishers with me. The pump I bought said it would go to 100 psi, but as you can see, testing shows it only goes to about 50 psi, but it does increase the amp draw to about 6.2 amps. I'm not 100% sure if I want a smaller orifice, which will have more pressure but less flow, or go to a larger orifice, which will have lower pressure but more flow. Get that switched out. Look at the pressure gauge, and it only goes up to about 20 psi on the smaller orifice. With the testing done, we'll pack everything up, head back inside, and actually start to build the flamethrower. I'll start by bending a 5/8 piece of rebar into the shape of a handle. Once it's heated up, I'm able to put the pipe on there, get it bent off, then I'm going to head over to the chop saw and cut a few pieces of angle iron. By this point, the rebar is cooled enough so I can get that cut. Then I'm going to head back to the workbench and use the oxyacetylene torch to bend another handle. I kind of have the basic design in my head, but I don't have anything down on paper, so I just start building. This is going to end up being way heavier than I originally expected. And I'll probably do a version 2 in the future that'll be lighter and more compact. With the frame mostly built, I'll head back to the workbench and start to assemble all these pieces together. For safety reasons, I'm going to put a 3-foot piece of copper tubing on the frame so I can keep the flame as far away from the vinyl tubing as possible. I had an old drill laying around where the motor had gone out on, so I'm going to cut the top of it off so I can easily attach that to a battery. Then I'm going to attach that to a buck converter so I can drop it from the 20 volts of the drill down to a safe 12 volt for the pumps that I'm going to be using. To hold the different flammable solutions, I'm going to be using these gallon jugs. I'll drill a hole in the bottom, install a washer, install a gasket, then screw in a barbed fitting from the bottom. Head over to the sink, fill it with water, and do a little test to make sure I don't have any leaks on that bottom gasket. Head back to the workbench, straighten out this piece of copper tubing as much as I can, then I'll get it cut to length. Now, in order to make the tubing as straight as possible, I learned this trick a while ago where you can take a board and gently roll the tubing out. This helps straighten it out even more than those rollers could before. On one side of the tubing, I'll go compression to 1/4 inch, 1/4 inch to 1/8 inch, then 1/8 inch to that orifice nozzle that I took out of a furnace. On the other end, I'll go compression to 1/4 inch, then 1/4 inch to barbed fitting, which will then go to the vinyl tubing. And with the basic setup done for the first one, now I just need to repeat this another 3 times. I'll bring the flamethrower skeleton over, get everything wired up, then start to hook up all of the tubing. Head over to the electronic workbench, cut some wires to length, then throw on some heat shrink connectors on there. Then I'll go and wire up these relays that will control the 12-volt pumps. Head back over to the main bench and get everything mocked up and make some final tweaks. As I get all of the electrical connections hooked up on this rough draft of the flamethrower, I'm also going to make an anti-flamethrower, which is just a backpack container hooked up with a small pressure washer. Next, I'll be mixing up the fuels that I'll be using in this particular project. This is denatured alcohol with lithium chloride mixed into solution. Once it's done, I pour it back into the gallon can and be very careful not to mix the cans up with each other. Next, I'm going to head over to the sink and mix up 2 gallons of nitromethane with denatured alcohol. Trenton was gracious enough to let me come over to his farm, go out to one of the back pastures, and play around with the flamethrower a little bit. For this first part, I'm just testing straight denatured alcohol, and this will be the Blue Flame. Once I'm satisfied that everything works correctly, I'll go back to my truck and add the red flame, which is lithium, and the white fuel, which is the nitromethane. One of the things that I find extremely interesting about this project is all 3 fuels are completely clear, and you cannot tell these fuels apart until you actually start to see the flame. I've also got a few zip ties on these momentary switches up top so I can remember which button shoots which fuel. Now the only thing left to do is to go have some fun with this project. I wasn't quite sure how this would turn out, but so far I'm pretty happy with how this version has turned out so far. One issue I'm having is the nitromethanol doesn't want to burn in the air, it really only burns once it hits the ground. The other thing is the red and the blue flame has too much flow, and it's getting more fluid on the ground than it is burning in the air.
So this was our backup option if the fire got far, far away. 5 gallons of portable water. Here, let me just look at this here. And if this didn't work, we've got this, plus the backup to the backup to the backup fire extinguisher, plus the backup to the backup to the backup to the backup fire extinguisher. So I think we were good.
We'll drain out all the fuels, I'll head back to the shop and make a few other tweaks to this. The biggest change I'm going to make here is to switch out all of those orifices to the smallest size I have. Get everything fueled up, then we're going to take it out for a small test. It's going to take a little bit to purge the lines. Once the line is purged, I get the beautiful flame like I've wanted the entire time.